Hey, so let's do the chapter 4, section 4.2, the mean value theorem. In this, we are going to do two theorems. One is the Rolle's theorem and another is the mean value theorem. Let's see what does it say. So the Rolle's theorem is like if you have a function that is continuous on the closed interval AB and it is differentiable on this open interval AB with fa equal fp. So the value of the function at point A and the value of function at point B, if they are equal. So we have to set up the function like that. So let's see this. Here the graph is rising and turns around and it falls down. This interval is A and B. F is continuous on AB in the closed interval and it is differentiable. So the Rolle's theorem says that if f is continuous on the closed interval and if f is differentiable on the open interval AB with fa equals fp, then there is at least one point where the derivative of the function is 0 or the tangent line is a horizontal line or the slope of the tangent line at that point is 0. Sometimes there is more than one c. It depends on how many times it falls and rises again, but Rolle's theorem is for when this fa equals fp. Let's take an example, and we have to set up the whole all the three conditions have to be met. So let's take this example, fx equal x times square root of x plus 6. It is given the closed interval -6, 0. So does it apply here, the Rolle's theorem, on this function? Let's see. Is the function continuous on this interval? Use your calculators, draw the function. Do you see any discontinuity? I don't think so. So the function is continuous. Is it differentiable? So there is no discontinuity in that or anything. Then yes, the function is differentiable. And is f of -6 equal f of 0? Yes. So the Rolle's theorem does apply to this function. And now we have to find the value of c, the point where the derivative equal 0. So let's try to do that. Let's try the function, the derivative of that function. Let's see, let me select my pen. Okay, so over f, if f of this, f dash x would be square root of x plus 6 plus x over 2 square root of x plus 6 using the product rule. Now we have to put that this equal to 0 and solve it to find x. This would be equal to 2 times x plus 6 plus x equals 0, 2x plus 12 plus x equals 0. When you solve that, you get x equal -4. So this is your c. So this actually is the value of c, the point where the derivative is 0. So that's how you find your c. You probably cannot see the graph, so let me go back. Okay. So that's when you draw the graph. So this is your c where the derivative is 0. at -4 here. I'm not considering the y value, I'm considering the x coordinate, -4. Now, next is the mean value theorem. Mean value theorem says that there has to be, again, the two conditions, that f is continuous on the closed interval AB and it is differentiable on the open interval AB. Here I'm not saying that FA equals FB. That's not the condition for mean value theorem. Only two conditions, that f is continuous on closed interval and it is differentiable on the open interval. Now now if you draw a secant line through this point A and point B, what would be the slope for this line? The slope is FB minus FA over B minus A. It's y2 minus y1 over x2 minus x1. That's the slope of the secant line. Now, the question is, can you find at least one point on the curve where the tangent line is parallel to the secant line? That means the slope of the tangent line is exactly same as this secant line. Yes, there would be a point here and a point there. So yes, there is at least one number, or the point C in AB, for which the derivative of C equals this, that is the slope of the secant line. That means the slope of the tangent line is same as the slope of the secant line, or you can say the instantaneous rate of change is exactly same as the average rate of change. Okay, so, or in other words, you can say that there is at least one point P between points A and B on the curve where the tangent line has the same slope as the secant line through AB. So in this picture I've put P, A and B instead of X, Y, X2, X1 and so on. Okay. Let's take an example here. So this says that, okay, the mean value theorem gave me a speeding ticket. The problem is that speeding limit on the Garden State Parkway is 65 miles per hour. Okay. One day in August, a police camera captured my car as I got on the parkway at exit 129. You know that they're all like a mile apart on the exits. 36 minutes later, another camera caught me exiting for the shore at exit 82. I wasn't pulled over, no one clocked my speed with radar or anything. And a week later, I got a speeding ticket in the mail. Why? Let's see. Now, got on the parkway at exit 129 and off at exit 82. That means how many miles did I drive? 47 miles. I covered the distance in 36 minutes. That's what given in the problem. So what was my average speed on the parkway? And rounded to one decimal place. So if you do that, you get 78.3 miles per hour. If you divide 47 miles by 36 minutes and convert minutes into hours by dividing 36 by 60, you get 78.3 miles per hour. Now, fine, the average speed is here, the total miles is here. How is the mean value theorem applied to give me a speeding ticket? Why? How? So, because it says that at some point while traveling, at some point, at least once, my instantaneous speed was equal to this average speed. And this is about 13 miles per hour more than the speed limit. So that's how I got the speeding ticket. Another example, like find a value of C satisfying the mean value theorem for fx equal x plus 1 over x on the interval half and 2. So plot that graph, you can see that this is continuous on this closed interval and it is differentiable on this. What do you have to do to apply the mean value theorem? You have to find FA and FB. So you have to find F1 and F2. F1 is actually half and F2, so half is when you calculate that, so this is half plus 1 over half, this is 2 plus 1 over 2. Half plus 1 is 3 halves over half, this comes out to be 3, and F of 2 comes out to be 3 over 2. B minus A tells you 2 minus half, this comes out to be 3 over 2. Now calculate, you have to find this, that is the derivative at this C has to be equal to 3 over 2 minus 3 over 3 over 2. Calculate that, this comes out to be negative 3 over 2 over 3 over 2, that is negative 1. So that's your answer for this. So the C value, C is negative 1, where the derivative is exactly same as the slope of the secant line through these 2 points. The consequences of this mean value theorem, or MVT for short, is that if f dash x, the derivative of the function, equals 0 for all x in some interval AB, then the function is constant over that interval. If the derivative is 0 constantly, that means it's constant. Pretty obvious here. Now if the derivative of gx equal the derivative of fx, that means the derivative of one function equal to the derivative of another function for all x in some interval AB, then in words I'm telling you that means the functions differ only by some constant. So this tells you that g dash x minus f dash x equals 0. The difference of the derivative is 0 on that interval. So that means there's just a difference of a constant between that. What does that tell you? That if it is gx equal fx plus c, that means there is just a vertical shift. Two functions whose derivatives are equal differ only by a constant, or you can say that they differ only by a vertical shift. If two graphs have the same slope at every point on an interval, then the graph differ only by a vertical shift. Let's take an example. You have to find all functions that have a derivative equal to 4x cubed plus 2x minus 1. What could be those functions whose derivative is this? So let's see. This could be x to 4 plus x squared minus x plus, let's say, 3. It could be x4 plus x squared minus x minus 100, or it could be anything. So they are different only by a constant here. You can keep changing it. Even if you take, if this is your, let's say this is f1x. If you take the derivative of that, it is still the same. 4x cubed plus 2x minus 1. The derivative of this would also be the same thing as 4x cubed plus 2x minus 1. So if the derivatives are equal, the functions differ only by a constant.